All right, I'm going to go ahead and get started, everybody. Thanks for attending my presentation. My name's Darren Nattinger. How many of y'all are at NI Connect for the first time? Welcome. Super glad that y'all are here. Howdy. I'm a native Texan, so it's okay for me to say that. I'm a native Texan who's never owned a pair of cowboy boots or a cowboy hat, so not all the stereotypes are what they seem. I've worked at NI for over 26 years. Most of my time at NI, I was in LabVIEW R&D, but for the past 5 years or so, I've been in the technical support organization at NI as a chief engineer, helping NI figure out how to support our LabVIEW customers better. That's been my job for the past 5 years. Prior to that, I was making LabVIEW better for you guys by adding features to it. But today, we're not here to talk about LabVIEW features that I worked on. We're here to talk about DQMH, which is the world's most popular third-party framework for LabVIEW. How many of y'all attended Casey's presentation earlier today about Actor Framework? Okay, so we got a few of y'all. Here you're gonna see sort of a contrast between what I think are the two most popular frameworks for LabVIEW, Actor Framework and DQMH. So it's good that y'all got an introduction from them. You're gonna see a lot of the same themes in my presentation. You're gonna see a lot of talk about the queued message handler and how some of the ideas or concepts behind that are similar, because at the end of the day, we've got multiple loops running in parallel that need to communicate between each other. And what is the framework that we're setting on top of those in order to be successful LabVIEW programmers? Before I get started though, I want to point out that if you've never met me, if you've never seen any of my content before, I talk about LabVIEW a lot. I give a lot of LabVIEW presentations. This presentation I'm giving you today, I gave at NI Connect last year, and I gave at the NI Connect the year before that, and I've given at many user groups. And I've got a whole library of presentations available, and they are all at dnat.org. I'm assured that we're not going to have any power outages this afternoon. However, if we do, y'all could go to dnat.org and download the slides for this presentation, and you'll be able to follow along on your laptop if I suddenly lose my screen. Hopefully that won't happen. This particular presentation is at bit.ly/dnat DQMH intro. Also, there is a tool I'm going to use while I'm doing my demos later called Zoom It. If you ever give a presentation in front of people like I'm doing now, I highly recommend you use this tool because it makes it really easy to sort of zoom in on things on the screen, particularly when there's resolution and people in the back of the room and you really want to focus on something. You're going to see me using that tool several times when I do my demos later on. So since I'm talking about a framework, I'm talking about a LabVIEW framework, I'm going to be using a lot of terminology. And so I like to start off the presentation by going through and defining my terminology. And there might be some terms I'm about to cover in these slides that you don't agree with my definition. That's fine. Just know that that's what I'm going to be using. Like, for example, I'm going to define the term framework. I'm going to define the term design pattern. You may not agree with my exact wording of that definition, but at least you'll know what I mean when I say it during my presentation, right? So first off, I'm going to use the word process quite a bit. And when I talk about a process, I'm just referring to continuously running code. And that is almost always something sitting inside of a while loop in LabVIEW, right? One or more while loops. I'm also going to be referring to reentrancy some during this presentation. If you're new to LabVIEW, if you're not sure what that is, that basically means multiple VIs that basically multiple copies of the same VI running in parallel. That's what reentrancy is. I'm also going to use the term API. I'm not a computer scientist, so I'm probably using this term incorrectly. I'm just going to, when I say API, I just mean a group of functions that are related to one another. For example, you can see in the pictures there, I've got the file IO API. I've got the TCP API. Basically, functions that are related to each other. I'm also going to use the term business logic. When I refer to business logic, I'm talking about the code that you need to write specific to your application that isn't at all related to your framework. For example, later on in the presentation, I'm going to be talking about the automated teller machine example. The one on ni.com when you're practicing for the CLD would tell you to write an automated teller machine. And if you've got code in there that's doing some math to calculate what somebody's balance is after they've withdrawn some cash from their account, that's an example of business logic. That's something that your code's going to need to do no matter what framework you have sitting on top of your code. I've got some more glossary. I'm going to use the term synchronous sometimes. And when I use that term, I'm basically meaning things that have to happen in a certain order. If you look at the picture there, you can see process A has to run first, process B can't run until process A is done, et cetera. That's a synchronous process. Compared to an asynchronous process where the processes are independent from one another and they can run in parallel. I'm going to be talking about queues. Queues are an API in LabVIEW that allow you to pass data between processes or to pass data inside of a process. And guess what? Events are the same thing. You might be used to thinking about events in LabVIEW as things that happen when you click a button on the front panel or change the value of a numeric. But there's also programmatic events in LabVIEW. They're called user events. And they provide very similar functionality to queues. They're a way to pass data between multiple processes or within a process. I'm not done with the glossary yet. So, a design pattern. My definition of a design pattern is a theoretical mechanism for executing synchronous code or asynchronous code. An example would be a state machine. That's a theoretical mechanism. And we can all sort of picture in our head what a generic state machine might look like. Then you've got architectures, which are basically something in the real world. So now instead of theoretical things, something in the real world that's going to use possibly multiple design patterns to accomplish having code run in parallel in an asynchronous manner. And I've got a few examples on the slide here. The JKI state machine, I consider an architecture. If you're familiar with TLB Prime or Messenger, I also consider those architectures. And then my definition of a framework. A framework, in my definition, is a consumer-grade architecture. So something that has been built specifically for other people to use. It is well documented. It has tooling sitting on top of it to make your experience as a developer more streamlined. In my estimation, there are 4 publicly available frameworks in the LabVIEW community, and I've got them listed in the slides here. Actor Framework, DQMH, State Machine Objects, and Workers. In my opinion, those are the frameworks that are available to us in the LabVIEW community. If you are not writing your own framework, you're probably using one of those. And y'all just saw a presentation earlier today about Actor Framework, and I'm going to be talking about DQMH today. I think most people would agree those are the 2 most popular frameworks in the LabVIEW world. All right, so you see up there in the design pattern section, I have highlighted in red the term queued message handler. All of these frameworks, all of these patterns, they're built on the concepts outlined in a queued message handler. So let's spend a minute talking about the NI queued message handler. And again, if y'all were in Casey's Actor Framework presentation this morning, some of this is going to look pretty familiar. Casey said that his slides were inspired heavily by me. Actually, they were copied directly by me in some cases. So seriously though, the NI QMH has been around since 2012. It's been around for a long, long time. The concept of a queued message handler has been around even longer than that. But NI actually codifying what is a queued message handler, that happened in 2012. It was shipped as a project template, still available in LabVIEW today. And if you think of a queued message handler, which I think you guys indicated most of y'all are familiar with, this is what you imagine. You imagine 2 loops, an event handling loop sitting on top of a message handling loop. That is what a queued message handler is to most LabVIEW programmers. Now, LabVIEW ships with some sample projects that are built on top of the queued message handler. So actual real world code that you can use to implement your applications. This is an example of the continuous measurement and logging sample project. So if you have a need to continuously acquire and log data to disk, you could literally start with this thing. And assuming you don't have to do a bunch of customizations, you could be largely successful with this thing. You can see that it has a similar structure to the queued message handler. The top half of that diagram should look very familiar. It's got an event handling loop. It's got a message handling loop. But there are extra message handlers that have been added to the continuous measurement and logging sample project. You've got one for doing your acquisition. You've got another one for doing your logging. And when you do this, when you add message handlers to your code, you need to add queues to be able to pass data between the different processes. Remember, processes are loops that run in parallel, and here we have 5 loops running in parallel, and we need some way to communicate data between those. Now there's a few problems with NI QMH. This is the slide that Casey stole from me. First, the communication between processes isn't all that straightforward. So you saw that I had several loops going in parallel, right? Event handling loop, message handling loop, acquisition loop, logging loop. So what if I need to add a database loop? Now I need to take my data and not only log it to a file, but also log it to a database. Well, now I'm going to have to create a new queue. I'm going to have to pass that new queue to all the people that might need to message that database loop. And this isn't scalable. The more loops that you add, the more queues that you manually have to add to your code. And probably the most difficult part is once you've got all these different possible processes that could be messing with your queues, how do you debug when something goes wrong? How do you figure out which of these myriad different possible places is putting something in the queue that's not supposed to be there. That can be difficult to debug. Another problem is that you lose a lot of reuse possibility when you're using the standard NI QMH. That logging loop that was in the previous slide, maybe that's really useful. Maybe it's logging to TDMS. Maybe I've got a new application I need to write, and it would be really useful to have a TDMS logging loop in that other application. Well, why don't I just copy that whole loop over to my new application? Well, I can't do that because that loop has references to queues for other loops in my main application. There's not reusability there. I'm gonna have to start hacking code out to make it work with my new code. It can be difficult. I mentioned reentrancy earlier. What if I need to have multiple acquisition devices running at the same time that I want to log data from? Can I just take that acquisition loop VI and change it from non-reentrant to reentrant and expect things to just work? No, there's no way I can do that because there's a whole bunch of other stuff I have to do. And probably the most annoying part about using the NI QMH is that 100% of the work that you do at the framework level is manual. When you need to add a new queue to pass data between loops, when you need to add a new loop itself, when you need to add a new message to your message handler to be able to do something, you're doing all of that work manually. So now you've got this possibility of making mistakes when you're adding your queue and making it the wrong data type and typing in the names of messages wrong. Those are all things that you have to do manually and are subject to error. So that's my background to introduce DQMH. Hopefully, as I go through this next part of the presentation, I'm going to answer a lot of the questions about the shortcomings of the NI QMH. So first, I'm going to give a little bit of history. DQMH came out 10 years ago. That was the first public release of DQMH. And it was originally developed by Delacorp, an NI Alliance partner. The chief architect of DQMH has graced her with her presence in the room, Fabiola de la Cueva. And a year after it came out, DQMH was named the LabVIEW Tools Network Product of the Year. There was a big award ceremony at NI Week at the time where they received that award. And a few years after that, the DQMH Trusted Advisors Program was started, which is a group of individuals who have basically been vetted as being DQMH experts who can provide assistance to the community on DQMH development. And then back in 2021, a nonprofit organization called the DQMH Consortium basically took over ownership of DQMH. And then present day, the latest version of DQMH is 7.01, and that's what I'm going to be demoing in whenever I get into the code later in the presentation. So that's a little bit of history for you. This is a well-established framework that has been around for 10 years at this point that has a large group of what we would call trusted advisors who are LabVIEW programmers, developers, consultants who are very skilled at DQMH. So DQMH is free. You can install it from VIPM. You just search in VIPM for DQMH. You can go to vipm.io and search there. That's my favorite tool for getting LabVIEW add-ons, vipm.io. And what is it? Well, hopefully this is clear at this point. It is a framework for large LabVIEW application development. It is the most popular third-party LabVIEW framework in the world by a large margin. And it's so popular that it, I believe, is I know, it's the only third-party product that has an NI badge that you can get for it. On the NI badging program, ni.com/badges, you can get a badge on LabVIEW syntax or LabVIEW basics or data acquisition fundamentals or DQMH or active framework. So it's a way to basically learn more about fundamental aspects of LabVIEW programming. Now, let's get into a little bit of implementation details. When I write my demo later, if you're familiar with the NI QMH, you're going to see that I'm using a queue for a process to send data to itself. That's how the NI QMH works. That's how DQMH works as well. The big difference is that under the hood, DQMH uses user events to pass data between different DQMH processes that are running in parallel. Now, some people aren't as familiar with the user events API. I showed it in a picture earlier when I showed queues and I showed events, and it's a way to programmatically generate events. And one of the great things about DQMH that you're going to see in my demo, I'm going to spoil it a little bit, but I'm going to write exactly 0 user events-based code because DQMH tooling is going to create all of that stuff for me. So just remember, under the hood, DQMH is using user events to pass data between processes. If you're curious, Casey didn't cover this earlier, but Active Framework uses queues to pass data in between events. So that's one significant difference between the two frameworks. The main thing that we want to take away about DQMH and its design and why it works the way it does is that the whole point, Fabiola's main goal when she was working on DQMH and designing it, was that she wanted this to be a framework that was accessible to CLAD and CLD level LabVIEW programmers. And there's multiple ways that she did this. One is the fact that when you're writing your business logic, it feels very much like you're using an NI QMH, which is useful, just in terms of familiarity. Another reason is that DQMH uses LabVIEW classes very little out of the box. It does use them. You'll actually see a class wire on your DQMH diagram, but you will typically not interact with it that much, if at all. So in terms of being accessible to CLAD and CLD level developers, some people would argue that LabVIEW classes themselves should be accessible to entry-level LabVIEW programmers. I have not found that to be the case. I've found LabVIEW classes to be a stumbling block for a lot of LabVIEW programmers. That's fine. That's one of the reasons DQMH is so appealing to teams of large, a wide variety of skill sets, is because of the minimal use of LabVIEW classes out of the box. All right. What's that?
You can add them.
Well, you can do whatever you want. It's LabVIEW. So, so earlier I had a glossary of generic terminology I used during this presentation. Now we're going to get into a little bit of a glossary of DQMH because there's some terms that I'm going to start throwing around, especially when I do my demo. I want to make sure y'all are familiar with those terms. The first term I'm going to use is a DQMH module. This would be equivalent to an actor framework. So DQMH module is the basic building block of DQMH. It is the, when you want to create a new asynchronous process, you want to create the process that's doing your acquisition or that's doing your logging, then you would probably have an acquisition module or a logging module. And in DQMH, a module is a library, an LV-lib file. And it can be, you can see I have the terminology on the slide, singleton or clonable. That just means non-reentrant or reentrant. Not really going to get into the details of that in this presentation since this is an intro presentation, but that's basically if you want to have multiple instances of your module running at the same time, you can make it clonable. Otherwise, you'll make it singleton. All right, so we've got this module running. Let's say it's an acquisition module, and we would like for the acquisition module to start acquiring. What we would do is we would send a request to that module. And a request is a way for us to ask the module to do something. It's called a request because it's not a command. We're not telling the module to start acquiring. We're asking the module to start acquiring because maybe the module doesn't want to acquire. Maybe something's going on in its internal state. Maybe it had trouble accessing the DAC board or whatever. But the reason we use that terminology is because we're always going to be asking a module to do something. That's why it's called a request. And the way a request is exposed to the outside world is a sub-VI call. That's what the picture is there. We've just got a sub-VI that we're going to call, and we're going to ask, in this case, I think it says start timer. So this is a request that's going to say, hey, can you please start a timer? It's just a sub-VI call. That's all it is. Another term is a broadcast. So if a request is a way to ask the module to do something, a broadcast is a way for the module to tell the world something. So maybe you've got your acquisition module, and it has started acquiring, and it wants to tell the world that it has started acquiring. So that would be an example of a broadcast. Acquisition module would tell the world, hey, everybody, I started acquiring. Maybe there's one person that's interested. Maybe there's 2 people that are interested. Maybe there's 0 people that are interested. Doesn't care. It's just going to tell the world this thing. If you remember nothing else from my 1 hour of your time, remember this slide, because this is, in terms of introduction to DQMH, this is the intro. This is the most basic of basics for DQMH. And I'm going to be using these 3 terms extensively throughout my demo. So just remember, the module is the asynchronous process that's doing a thing. You can ask the module to do something with a request. The module can tell the world something with a broadcast. If you remember those 3 things, then you successfully passed my introduction to DQMH class. All right, so what are some other terminology that we need to use with DQMH? A main VI. You're going to see me do a lot of programming inside of the main VI for my module here later in my demo. That's where the business logic goes for your code. Nobody needs to see that other than you, the person who's developing the DQMH module. There's something in DQMH called the API tester. It's one of the most useful things in DQMH, and it's a way for you to continuously make sure your code is working while you're working on your module. Once you implement a request, once you implement a broadcast, you can immediately be able to test that request or test that broadcast without having to do any extra work because the DQMH framework maintains this testing tool for you. My tester is going to be very useful for me when I do my demo later. And the thing that makes DQMH framework a framework is the scripting tools. So remember I said earlier, a framework, my definition of a framework is a consumer-grade LabVIEW architecture, something that's been designed specifically for other people to use. And that's how, if you ask Fabiola what's the greatest thing about DQMH, she's not going to tell you, oh, my brilliant design of how this internal communication works. She's not going to say that. She's going to say the scripting tools. Scripting tools are the best part about DQMH framework because that is what gets you up to speed having a functional application as quickly as possible because all of the manual work that you would normally need to do for framework level development is handled for you. All right, you guys ready to see me do some live LabVIEW coding?
He's the fastest LabVIEW developer.
And did anybody see when Casey earlier this morning was trying to do his demo up there and he had like his hand up on the top of the thing and yeah, you can see why I moved everything down to this table right here for my demo. So what am I going to do? I'm going to write a timer module. How often do we need a timer in LabVIEW? We need to time something. We need to say, hey, this needs to run for this many seconds, or hey, we need to stop if something happens in the middle of it. A timer is a very common need in LabVIEW, so I'm going to write a DQMH timer module for you guys today. It's going to be very simple. I don't have time to write a completely functional timer, but what it's going to be able to do, it's going to be able to start for a duration. You can tell it to stop, and it's going to tell the world whenever the timer has elapsed. So those three things tell us that we need two requests, right? We need to ask the module to start with how much time we want it to spend, or I'm sorry, ask the timer to start. We need to ask the timer to stop, and we need the timer to tell the world whenever the time has elapsed. So those are the things that my timer module is going to do. I'm going to sit down here with my microphone and my mic stand, and I'm going to write some LabVIEW code. Do y'all have any questions or comments before I switch over to LabVIEW? Oh, my boss has had enough. He's getting out of here. Oh, no, he's taking a picture. All right. All right, so let's go over to LabVIEW. So I've got a blank project. When I said I was going to write one from scratch, I meant I'm going to write one from scratch. So the first thing I'm going to do is I'm going to create a DQMH module. And if y'all have any questions about any of the stuff I'm doing during the demo, just shout them out. It's fine. Or I guess if anybody wants to walk around with the mic, that's cool too. But we're going to call it timer, and we're going to say this timer can start and stop, and we're going to go ahead and give the library an overlay that says timer, and we're going to make it red, and I am ready to create my module. So this is an example of one of the scripting tools in DQMH. Everybody can hear me okay, right? I've got the mic in a good spot. Okay. This is an example of a scripting tool in DQMH. I did not need to manually create this module. I ran one of the scripting tools, and as you can see in my project, it created, and here I'll zoom in a little bit. It created an LVlib, which remember a DQMH module is an LVlib, and it created a tester. So those are the things you get when you make a new DQMH module. So obviously, I've got a good start, right? But I don't actually have any code written yet, so I need to go ahead and write some code. So remember, I said I need two requests in one broadcast, right? Start the timer, stop the timer, tell the world that the timer elapsed. So let's go ahead and create those. Once again, I'm going to go to the DQMH scripting tools. I'm going to create a request, and I'm going to call it start timer, and I'm going to give it a parameter that is the duration of the timer, and I'm going to give it a description that says this request starts the timer for the specified duration, and I'm going to run the scripting tool, and it's going to create basically the request for me. So this VI that you see right here is not my module. This is my tester. When I talk about DQMH, there's two main things that I work with a lot, and that's my module VI, my module main VI, and my tester. And right now we're looking at the tester. So this is not the actual timer code. This is the way we test the timer code. We can see that we're given some bookmarks that tell us the things that we need to change. I'm going to go ahead and follow the instructions in that bookmark, which is to create a duration control for being able to test the start timer request. And I'm going to make the text on that a little bit bigger so we can all see it real good from the back of the room. All right, so I also need to create a request for a stop timer, right? So let me go ahead and do that. So once again, I'm going to launch the DQMH scripting tools. I'm going to create an event called stop timer, and I'm going to document it and say this stops the timer if it's running. And that's going to create another request for me. And once again, my tester has come up. And so I'm going to go on the front panel of the tester. I'm going to move this button over. And then I've got one more thing to create, which is my broadcast that tells the world the timer has elapsed. So I'm going to go ahead and write that too. So once again, I will run the DQMH scripting tools to create a new event. This time I'm going to create a broadcast. It's going to be called timer elapsed. The timer has elapsed. I'm going to go ahead and click OK. It is once again bringing up my tester. And I'm going to go ahead and make a few changes on the tester diagram. And I'm going to put in a text right here for the broadcast that says timer elapsed. OK. Now, believe it or not, I'm actually done with my tester. If we look at the tester front panel and we look at the stuff that I added ways to test the starting of the timer, the stopping of the timer, and then that code I just added on the block diagram is going to add messages in the status string that says the timer's elapsed. So my module is actually ready to test. The problem is, in case you missed it, I haven't actually implemented my timer yet. So I should probably do that, right? So let's go ahead and go over to the DQMH module main VI. So that's going to be right here. Let me scroll a little bit just so we have a little bit more space. I'll do some zooming if I need to for people in the back. So this is my main VI. This probably looks pretty familiar to you guys because we've got an event handling loop up at the top and we've got a message handling loop at the bottom. That looks a lot like the NI queued message handler, right? So if you're familiar with that pattern, hopefully you're familiar with using DQMH in terms of implementing business logic because this is something you've seen before, right? So if you've seen the NI QMH before, you know that there's this cluster of data that we typically use to pass information around that is going to be useful for our module. So in my case, I'm going to have a timer duration. I'm probably going to need to keep track of when my timer started, and I'm probably going to need to know if my timer is actually enabled. So that's the kind of local data that my module needs. You would be adding this to your data cluster for the NI QMH as well. That should be a very common pattern. So now that I've got that data, I like to always start with the simplest thing first. Maybe I shouldn't be like that, but I am. So the first thing I'm going to do is I'm going to initialize my state data for this cluster that I was talking about. So whenever we initialize, we're going to have just set zeros on all that stuff. And once again, let me go do another easy thing, which is I know that when I stop the timer, I'm going to need exactly that same code. So I'll go ahead and add that code here. The hard part's going to come later. I'm putting that off to the last. And then let's see, another piece of easy thing that I can do is probably the start timer code. So whenever I start the timer, I'm going to need to store a timestamp and say, hey, we've started the timer. So let me go ahead and do that. And we'll just drop that here. Whoa, let's not do that. OK, here we go. And let's see, we're going to say that the duration is whatever got passed in. And again, this looks a lot like regular QMH programming, right? I'm going to pass that in. Let's store a timestamp. And let's enable the timer. So this code is good. Now at this point, we're going to get into sort of the more QMH side of things. We're going to get into the business logic side of things. We actually need to implement the code that's comparing the times, right? So to do that, I'm going to do a little shortcut here, which is I'm going to have the message handler message itself to go check the time. There are other more elegant ways to do this. For the purposes of a demo that I'm writing live in front of everybody, I'm going to take the easy way out and just have the thing message itself. We're going to make a new message called check time. By the way, did you notice that all those descriptions that I typed in when I was creating the events, those are populated for us automatically by the scripting tools in LabVIEW, so that my code is, as long as I take the initiative to document the things as I write them, that documentation is going to be preserved in the code, and it's less documentation I need to go do as the developer. So let's go ahead and create that check time case and spell it correctly, and see if the timer has elapsed. Okay, so here's where I'm going to write my business logic. This is actually where I'm going to write code that checks my timer. So let's go ahead and pull out all that data that we might need, and we'll create a case structure here, and we'll control scroll because we always forget that does zoom now. And let's see, so what do I need to do? I need to do a timestamp. I need to subtract the stored timestamp from the timestamp I'm checking right now. I need to see if that's greater than the duration that was configured for my timer. And if so, then the timer's done, and we can go ahead and reset it like we did before, and we can broadcast to the world that the timer has elapsed. And that's what this little VI over here is. This was created by the scripting tools. So this is that broadcast that tells the world the timer has elapsed. Well, what if the timer has not elapsed? Then we will need to go in and say, hey, the timer hasn't elapsed. We need to wait a second because we don't want to spam the CPU. And then we want to go ahead and check the time again. So we'll put that here. I'm using a lot of shortcuts and everything, like quick drop and other keyboard shortcuts. If y'all are wondering how I'm doing any of this stuff, let me know. Okay, so we're gonna check the time again. And then, gosh, I think we're pretty close to being done here. Pass these wires through. And then I guess I'm gonna sort of look ahead and think, you know what? If at any point I need to debug this thing, it would be nice to have some information available on the front panel to be able to sort of look at and see if things make sense. So why don't I create an indicator of the, give me a second, Ben. Create an indicator of the current time and put that on the front panel and make that big so we can all see it. Ben, what's up?
Shouldn't the code be in the true state for enable?
Pay no attention to the man behind the curtain. Okay, so we're gonna go ahead and run our tester. We're gonna test our timer to see if it's actually working. So I'm gonna go ahead and run my tester. So this is my tool that I use to test my module. So I'm gonna run it. I'm gonna start my module. I'm gonna set my duration. And after 2 seconds, we should see a message in that string that says that the timer elapsed. But we're not seeing that. So I'm gonna click it again, because you always click things the second time, right? Just to make sure you didn't accidentally not click it the first time. All right, so there's, my timer's not elapsing. There's a bug in my code. Pretend that Ben didn't say anything earlier, all right? So I need to troubleshoot this, and that's why I intentionally, non-intentionally made a mistake earlier, because I want to see how I can use the DQMH debugging tools to figure out what's wrong with my code. So the first thing I'm gonna do is, and again, these are all built-in tools. I did not have to write any of this code. Y'all saw me write the code. I'm gonna click this button that shows my module's front panel. So the timer is you don't need to see the front panel of the timer because we only implemented it to basically broadcast to the world that something happened. So when I click the start timer, we can see that the time is not actually incrementing at all. So there's something wrong on my diagram. I'm gonna go ahead and use another DQMH debugging tool, which is to show the block diagram of the module as it's running. And I'm gonna go ahead and set a probe on this Boolean to see, hey, maybe my logic was wrong on that Boolean that I used to compare the times. So I'll go back over to the tester. I will start the timer again, and we see that my probe did not even execute. So that probe that I just set on that wire, right here, let's see, double click, that didn't execute, and that's where we see what the problem was, what the bug was that I introduced in my code. We can see that we're checking to see if our timer is enabled, but I put all of that code in there to check my timer, I accidentally put it in the false case. I accidentally put it in the case when the timer's not enabled. So that was my bug. And thanks to the built-in debugging tools in DQMH, I was able to find that bug and hopefully be able to fix it pretty quickly. So if I go back to the tester main panel, I'll go ahead and close it down. I'll go into the main VI. I'll go change that false case to the true case. And once again, run the tester and start the module and show its panel just in case we got to debug something some more. And set the duration to 2 seconds and start the timer. And we'll see that now the timer is incrementing, and now we see that we got this timer elapsed broadcast here. So I was able to use those DQMH debugging tools that are built into the framework to quickly narrow down and find my problem. That would have been a lot harder if I didn't have tools to be able to show my panel to debug and show my block diagram to debug. So that's the basics. I now have a timer module. Now, one of the first times I gave this presentation, somebody in the audience, after I did that demo, they raised their hand and they asked me and they said, okay, so now that you've got your module done, how do you actually use that? Do you go in and do you copy paste that code right there into some other place in your code for your timer? And when he asked me that question, I realized I had not done a good enough job explaining what's going on here. So I will answer that person's question with another question. Let's look at a VI in LabVIEW like recursive file list VI. If you've never used this VI before, I wrote it, but it's a way to point to a folder on disk and get back all the contents of that folder. Hopefully most of y'all have used that VI, it's pretty useful, right? Now when you want to get a recursive file listing, do you open this sub VI and copy its guts somewhere? No, you call that sub VI, right? So how do I use my timer? I call the public API of my timer. And let me show you guys what that might look like. I'm going to bring up the CLD sample exam for writing an automated teller machine. So that is right here. So if you have not taken the CLD or practiced for the CLD, you may not have seen this, but hopefully most of you have seen this. This is a sample exam for you to write a VI that simulates an automated teller machine. So you do things like you enter your PIN and you check your balance and you withdraw money and you check your balance again. One of the, or I guess here, let me actually withdraw some money. Okay, one of the functional requirements of the ATM is that if it sits there for 10 seconds of inactivity, like nobody's clicking anything on the front panel for 10 seconds, it's supposed to simulate like popping your card out and saying, hey, nobody's using this thing. I'm not gonna hold onto your card forever. I'm just gonna terminate your session. And as you can see, that's what just happened. While I was sitting here blabbering, 10 seconds went by, the whole VI stopped. That sounds like a job for a timer. Sounds like it would be useful to have a timer in my code that can count for 10 seconds and tell me whenever that 10 seconds has elapsed. Isn't that exactly what I just wrote earlier? So how do we use that timer module that I wrote as a demo inside of an application like this? Well, let's go look at the block diagram and see. Over here on the left, we're starting the timer module. And inside of this event structure, we're calling the start timer request anytime we want to start the timer. So basically, anytime the user does something on the front panel, clicks a button, types a character, inserts their card, we want to start the timer. And if they do something else, we start the timer again. So we're constantly restarting this timer and seeing if it ever elapses. And how do we know if it elapsed? Remember, a broadcast is the way the world tells us something. And in this case, the timer module is telling us that it has elapsed. And what do we do when it tells us that? We terminate the application. So this is a case where I have taken an application that needed a timer, and I have a DQMH module that implements a timer, and I call the public API of the DQMH module to implement that timer by starting the module, starting the timer, stopping the timer, registering for broadcast from the module when things happen. Does that all make sense? Is that all clear in terms of how I implemented the module and then how I'm using the module? Are there any questions about any of that stuff so far? Okay, so it turns out that the ATM that I wrote is itself a DQMH module. So I've got a module for the whole ATM. I've got a module for the timer. I also have a module that I have called Account Manager that manages the balances and everything. Let's look at some other code that calls DQMH, which would be this sample example that I have. So here is a main VI for an application. And this is just a dummy application. It's not doing anything terribly interesting. But this application happens to call two DQMH modules. One of them is called mySingleton. One of them is called myClonable. Not very creative names. But that's what this code does. Now, if we look at this block diagram, what kind of VI is this? Here, I'll give you a few clues. We've got an enum down here, wired to a shift register, wired to a case structure. We've got a comment up here that says main VI state machine. This is a state machine, all right? So this is not a DQMH module, but check it out. It's calling VIs and DQMH modules to do things like start a module and let's see, how about do something. And these are all, again, public API VIs of the module. And it's got all sorts of cases where we are registered for broadcasts whenever those modules tell the world something. This is a state machine. I didn't have to write a DQMH module to use my other DQMH modules. I'm comfortable with my main application being a very simple state machine, but I can still call the public API for the modules that I've written to be able to do things, just like I could call file IO functions or TCP functions, because the DQMH module has this API that the world uses to interface with it. Does that all make sense? Are there any questions? Pretty much done with the demo, getting back to the slides. If y'all have anything y'all want to see in LabVIEW before I do that. Okay. Oh, question. Oh, we got a mic for you.
How does DQMH work with like continuous data acquisition system?
Right, so the question is, I'll go ahead and stand back up with my mic. The question is, how does DQMH work with continuous data acquisition systems? Or maybe if I can more generalize that, continuous anything, right? Because with my timer, we were sending it a request that said, hey, go ahead and start. Like that's a discrete action that we needed to do. There's a topic I'm not gonna cover in this presentation, but it's called helper loops, where your DQMH module, in addition to having the event handling loop and the message handling loop, can also have other parallel loops that are doing periodic or continuous things. That's how you would typically implement that. If I had spent more time to do it the right way, for my timer module, I would have used a helper loop to do the checking of the timer instead of doing it inside the MHL. And DQMH also includes scripting tools for creation and maintaining of helper loops. All right, well, I'm going to go ahead and get back to my slides. All right, so there's two main developer roles when interacting with DQMH. Are you a DQMH module developer, like I just was when I wrote the timer module? If you are a DQMH module developer, you are the person creating the requests and the broadcasts for the module. That's your job. You're doing that. In addition to that, you are writing the business logic for actually accomplishing something with your module. So I developed the timer module earlier. I wrote the request for it, I wrote the broadcast for it, and I wrote the business logic for actually checking the timer and actually getting it to work correctly. So when you're a DQMH module developer, I forgot my clicker, you gotta keep your API tester up to date. Did y'all notice during my demo, before I even started on the business logic, what did I do? I made sure all of my requests and my broadcasts could be tested in my tester. I did that before I even implemented my timer. That's how important the API tester is. Some DQMH programmers think they can skip that step. Then when it comes time to debug their module, they're like, holy crap, why did I skip that step? You gotta keep your DQMH API tester up to date. There are lots of best practices, or some people might want to say better practices for programming in DQMH. I'm not going to cover those in my intro, but rest assured, it is documented in the link. Remember, dqmh.org, download these slides. That's where you can gain access to all the links in the presentation. You should never, ever, ever be editing user event code when working with DQMH. If you are editing the user events that got created by the scripting tools, you are doing something wrong. The scripting tools handle all of that for you. How many user events did I have to configure when I did my demo? 0. The scripting tools took care of all of that so that I could focus my efforts on making sure my business logic was correct. Document everything. I'm doing a live coding demo for you guys, and I still typed a description of every request, every broadcast, and the module that I created. The reason is there's a lot of tools that help your code stay documented when you do that. Y'all saw me show an example in the presentation where I zoomed in on that one diagram label that was automatically created for me. That was done without me having to do anything else. But there's other external third-party tools outside of DQMH that are even better for documenting code, and one of them is called Antidoc. I've got a screenshot there in the slide of what happened when I pointed Antidoc at my ATM code. And it automatically figured out that I have 3 DQMH modules, the main, the timer, the account manager. It figured out which ones have requests going between them, that's the green arrows. It figured out which ones have broadcasts going between them, that's the yellow arrows. And one of the coolest things that it shows me is that there's no arrows between timer and account manager, which means those are probably really reusable DQMH modules that I could use somewhere else, as opposed to seeing arrows go between them, which means they're coupled together as if I had written an NI QMH instead. Module templates are a great way to save time. I actually used a module template for creating my timer. It was a template that had a bunch of stuff stripped out to make it easier to start from scratch with my demo. Now, that was if you're a module developer. What if you're a DQMH module user? What if I wrote the timer module and I gave it to you? At that point, you're using the public API of the module. You are calling the sub-VIs that do the requests. You're calling the sub-VIs or you're registering event structures for broadcasts. You don't ever look at the business logic of the module, I guess, unless you're debugging it, but hopefully you're not debugging it because you're using one that somebody gave you that they said, hey, it's great, you should use it. You're not looking at the message handling loop. You are just calling the broadcast or calling the requests and registering for the broadcasts. If somebody told you download this module from VIPM, or if they gave you a VIP file, they better have created a palette for the public API for the module so that you can use Quick Drop or the palettes to be able to call those VIs instead of digging around on disk looking for them. But if they did not create a palette, then you can still find what you need. Typically, you will open up the library and see what VIs are listed in the public API. You can also open the tester. Hopefully, whoever developed the module kept the tester up to date, in which case they can copy over anything that they need from the tester. Now, DQMH modules always come with several requests and broadcasts that are just part of the module. Y'all saw me use a couple during my demo. Y'all saw me use the one where I show the front panel. Y'all saw me use the one where I show the block diagram. Those are built in. There's several others that are built in as well that, again, are going to be useful for you guys when you're trying to debug and make sure that your modules are working correctly. All right, so what are some benefits of DQMH? Why have I been talking about this framework for 45 minutes? Why is it the most popular third-party framework for LabVIEW in the world? Again, let's come back to the scripting tools. As the module developer, you are writing almost no framework level code. That is all being scripted for you. Creating new modules, creating new events, renaming events. Those are all things that are built into the framework, and you should never have to write any user event code because the framework is handling that for you. Also, another benefit of DQMH. Again, most of y'all indicated y'all were familiar with the NI QMH, which meant once I got into that message handling loop and started adding my business logic and updating the cluster for the message handling loop, those are all things that were hopefully familiar to you guys who are used to the NI QMH. Also, if you have an entry-level LabVIEW programmer on your team, maybe they're not as comfortable like doing framework level decisions, like what should the requests be for this module, or should this module be a singleton or a clonable? Maybe the architect on your team is making those decisions, but you can still appoint somebody and say, hey, add the business logic to this case structure right here, and chances are people are going to be successful with those sorts of tasks. And one of the best benefits of DQMH is frankly just sort of the nature of it being a framework and the fact that it handles things that are related to asynchronous LabVIEW programming that can be typically difficult when you're writing the code yourself. I've written plenty of VI server code where I've spawned asynchronous VIs, and then through some error, they were left running and I had no way to stop them, and they were zombies, and I killed LabVIEW.exe. That's happened to a lot of us that try to write code that runs asynchronously in parallel. DQMH handles that for you. Modules start when they tell you to start, they stop when they tell you to stop, and they report errors. And that is, I mean, that's why we should all be, even if you write your own framework, hopefully your own framework is solving those problems for you, because when I'm debugging my timer, I want to debug why my logic for my timer check was wrong. I don't want to debug why I told it to start and it never started. Those are things that you don't want to debug, and when you use a framework like DQMH, typically you don't have to. There's an active developer community for DQMH. I've got a link in the slides. Hopefully you guys are going to download the slides and be able to access that. The DQMH consortium, who is in charge of releasing DQMH, is very responsive to feature requests. Every release of DQMH includes several feature requests that are requested by the DQMH community. If y'all are familiar with the LabVIEW idea exchange on ni.com, where you submit ideas to NI for LabVIEW, the DQMH consortium has the same thing for DQMH, where you can submit feature requests for DQMH. And again, the links to all these things are in the slides. And Jorg Hampel blessed us with his presence. He is the person who runs the HSE site, and they have a lot more benefits of DQMH listed on their site, and the link is there in the slides. How are you going to learn DQMH? I have given you an introduction over the past 50 minutes. You're not going to be able to go out there and write crazy complicated DQMH modules at this point, right? You're still going to need to learn a lot of things about DQMH. There's a lot of topics about DQMH that I didn't cover today. I briefly mentioned a few like clonable modules and helper loops, but there's still a lot of stuff. It's a framework, for goodness sake. Of course there's a lot of stuff for DQMH. So what are your next steps, basically? Where do you go from here? I've introduced you to the framework. Hopefully you found some of the things I said to be compelling by the fact that you're still sitting here. So how are you going to learn DQMH? Well, it's got documentation. That's a great place to start, right? Got a link to the documentation in the slides. It's the documentation that comes with DQMH. It's updated with every release of DQMH, describing new features of the toolkit. There is a video series on YouTube called Tom's LabVIEW Adventure. It's an excellent introduction to DQMH. Frankly, though, it is a few years old at this point. There are several things about DQMH now that were not there whenever Tom made these videos, so that's one thing to keep in mind. The DQMH consortium maintains videos for teaching you DQMH. And there is a shipping example that, in my opinion, is a great illustration of how to use the public API for DQMH modules, so that's a good thing to look at. It's also a well-documented example. There's the official DQMH training course that the DQMH consortium provides. This is a course that you can take in person or virtually with a member of the DQMH consortium as your instructor for the class. I think it's a 3-day training. There's another way to learn DQMH, and that's my way. So I have a 1-day learning path for DQMH. It's a bit.ly/DQMH learning path. This is something that I came up with that covers the most common concepts and situations related to DQMH. It's a step-by-step guide that should take you about 1 day to get through. Step 1 is watching the presentation that I just gave to y'all. So you've already done step 1. So it goes through steps of covering a lot of the other things that I didn't cover in my presentation. This is not a replacement for the actual training course. In the actual training course, you get to talk to a DQMH expert who actually helps you look at your application and figure out your best next steps for what you're trying to do. So that's an amazing resource. But in terms of things you can do in a day to get more of a background, you can try my learning path. There are multiple ways that you can support DQMH. Remember that I mentioned before that it is a nonprofit organization. All of those scripting tools that I showed you guys, those are not free. The DQMH consortium pays developers to work on those features and improve the product. And so there are a lot of ways to support the continued development of DQMH. I've got the links listed there, like providing testimonials. There are several products that the DQMH consortium sells that are built on top of DQMH, like a test sequencer and a configuration editor. And then they have programs to be able to come and become enthusiasts and trusted advisors with DQMH. So I'll leave this one up just for a second since I see some people taking pictures of it. So these are the multiple ways that you can support the DQMH consortium in the continued development, maintenance, and improvements of DQMH. Are there any questions? Okay, we've got a few back there. You'll be, I think, number 3. What's up?
I missed the slide with the presentation link.
dnat.org.
Okay,
You
thank you.
can write that down. It's 9 characters. All right.
It's on that slide, lower right.
Oh, yeah, there it is. And there's that one too. Yeah, there's links all over the place. I think Katya had a question.
This might be a little bit more advanced, but in terms of using helper loops, is it laid out anywhere as to when to use them and when to make that decision of whether you use a helper loop or not?
So the DQMH documentation does have a page on helper loops that describes them and explains them. Just in one sentence, I'll tell you when you need to do something periodically in a DQMH module, you should use a helper loop. We could probably get more granular with our description of that, but that's the basics of it. And then if you find the DQMH documentation lacking in any further description, let me know. But I think that's the basics of it.
There's the blog post I wrote, which was the most popular one before.
Okay.
So that's another resource.
I think that's linked in the help too. Okay, we got a question over here.
Can you use the DQMH with real-time applications? Like, how does that live inside of either a serial or a PXI controller?
To answer this question, I bring on my guest presenter, Jörg Hampel.
Awesome. I managed to get on every stage that I see. The answer is very much yes. 3/4 of our applications are real-time applications, and we use DQMH for everything. So, yes, it doesn't look any different, really. There are nuances to how you maybe build your user interface if you have embedded UI enabled. But other than that, it's not too much
And your
different.
API tester.
Yes, the DQMH comes with the API tester that you showed, and for real time, there's a different variation of that you can also generate, which does not use the user interface events because they don't work in real time. So that's the difference. You have to use the other one, not the default one. I think that's pretty much it.
Anything else? All right, if y'all have any follow-up questions, come up and ask me. Thanks, everybody.